In this lecture, we're going to learn about const objects. Suppose you have a class like this. The class is called dog, and we have two sections in the class. We have a public section and we have a private section. Inside the class, we also have a few constructors and we have a destructor. But the important thing we want to look at in this lecture is the setters, which is this block here, and the getters that we have in this class. Now, we have this class declared. We don't have the definitions in here because we could move them in a separate file to keep the header clean. But suppose we created an object of this class and made it const. So we are declaring a dog object and it is made const here. And when we make it const, I want you to think about what this means. It means that you can't change any member variable in this object. Essentially, you can't change the dog name, you can't change the dog breed, you can't change the dog age. If you try to do that, you're going to get a compiler error. In this lecture, we're going to see some problems that come with declaring your object const. Then we're going to see a solution to this in a few lectures ahead. So if we have our object declared here and we tried to set the name to another name, for example, through the call here, you would expect this to fail because this object is const and we shouldn't be able to modify any member variable of this object. And set name is going to try and modify the name of the object. So this is going to give us a compiler error and we expect a compiler error. The problem is going to come if we try to call a function like print information here. And the printful function is really trying to read from the dog object. The main purpose of this function is, for example, to read the dog name and print that out, to read the breed name for the dog and print that out. It's also going to read the age and print that out. It's really not going to modify the object. But if we try to call this and compile our program, we're going to get a compiler error. This is even going to be the case if we try to read using any of the getters we have in the function. This is going to be even the case if we try to read the dog name through any of the getters we have in our class. So for example, if we say dog1 get name here, we're going to get a compiler error. So why is this the case? The problem is we have no special way to differentiate between the getters and the setters and tell the compiler that the getters aren't going to modify the data in the class and that the setters are only going to be able to modify. We don't really have a way to tell the compiler which methods are going to be modifying the object because we want our setters to modify the object, and tell the compiler that our getters are innocent. They're not going to try and modify the object. In the eyes of the compiler, our getters could also modify the object. So that's the problem here, and that's why we are getting a compiler error if we try to call any of these methods on a const object. Okay, so we have a problem. And the problem again is that we can't read data from our const objects, but we're going to get the protection from the compiler if we try to call the setter methods. But if we can't read from our objects are really going to be useless. We are going to see a solution to this in a few lectures ahead. But first, let's address some thoughts some of you might have about this problem here. Some of you might be saying, what if we try and go through pointers or references and try to modify the object or try to call our getters and see if things work? Well, I had to break it to you, that's not going to work either. But let's analyze these things case by case. Okay, so suppose we are trying to go through a pointer to non-const and try to see if we can call our setter or getter functions. So we have our object declared here, and we have a pointer to dog. Notice that this is a pointer to non-const. So this pointer could potentially be used to modify the object it is pointing to. And the moment we assign the address of our const object to this pointer, we're going to get a compiler error. The compiler is going to see that this pointer could be used to modify our const dog object. So it's going to stop us from doing the assignment here. So this is going to fail. This is not going to work. Okay, so our first attempt failed, but what if we try to go through a non-const reference? Let's see what happens. Again, we have our dog object. We are trying to set up a non-const reference to dog, and we try to assign our dog object to this reference here. Again, the compiler is going to see that this reference could be used to modify our const dog object and it is going to stop us from doing this assignment. So if we set up this assignment in our code, we're going to get a compiler error, and the compiler error is going to say we can't convert from const dog reference to dog reference, because that's what we are trying to do here. Okay, so what if we try to go through pointer to const? Let's see what happens. We're going to have our dog object, which is const, and we are going to set up a pointer to const dog. That's what we have here. And we're going to assign the address of our object to this pointer. So this is going to work. This is going to compile. But the moment we try to call a setter to our dog object, we're going to get a compiler error. And this is expected because we have no business modifying a const object. But if we try to call an innocent getter function, which is not going to really modify our object, we're also going to get a compiler error. And this is the same problem we saw before, but I want you to see this in the context of pointers and references here. So this is also not going to work. Okay, so what if we try to go through const references? We're going to set up our dog object, and we're going to set up a const reference here, and we're going to assign our object to this reference. And the moment we try to go through our reference to modify the object, we're going to get a compiler error, which is what we expect. But you see that if we even call our printing function here, we're going to get a compiler error that we don't really expect. So this is a problem with const objects, and we need to find a solution to this. So we have seen that const objects are really problematic, and if you set them up, you're going to be protected from changing your objects from the setters, but even your getters, which aren't really modifying your object, the compiler is going to prevent you from calling them. And this is the problem I really want you to see and keep in your mind. Now that we have really described the problem, it is time we headed over to Visual Studio Code and show you how this works in practice. Okay, here we are in our working folder. The current project is const objects. We're going to grab our template files and put them in place. Let's copy this. And we're going to put that in our folder. And we are going to open this in Visual Studio Code like we always do. Let's drag and drop here. We have our folder open. Let's open the main CPP file and clean it up a little bit. The first thing we're going to do is to create our class that we're going to be using to learn about the problems you might come across if you use const objects in your C++ program. So we're going to come to the left sidebar here and click on the plus icon, which says new file here. We're going to create our header file, which is going to be called dog.h. And we're going to create another file, which is going to be our CPP file. Let's close the Open Editors menu here because it's confusing me. So we're going to also create a CPP file. We're going to say dog.cpp. And I am going to put in the code for the class because I have it prepared. So let's paste that in here. I have the code in the header. I am going to go to the .cpp file here, which is open, and I'm going to put in the code that I have prepared. Let's go through this class a little bit because I don't really want to waste your time typing this. We're going to look at it and we're going to see how it's made. Then we're going to try and use it. We have a class. It's called dog. It has a public section and a private section. Notice that our member variables now have been changed to string view because we want to avoid copies when we pass parameters to the constructors here. So that's the reason why we used std string view here. We also have a third member variable, which is of unsigned int because the age can't really be negative. So it makes sense to make this unsigned. And if you go on top here, we also have a few other functions. We have our getters, get name, get breed, get age. They are going to be returning our member variables. We have a couple of setters. We have set name, set breed, set age. They are going to be setting data to our member variables. We also have a utility function, which is called printful, and it's going to print information about our class. So this is the definition of our class, but in the definition of the class, what we have are the prototypes for the functions. The definitions for the member functions are going to live in dog.cpp. And if you go in dog.cpp, you're going to have an include statement here. We're going to have our constructor, which is going to use the parameters to initialize our member variables. We have our getters, and all they will do is really return the member variables. One thing you should notice is that we have the scope resolution operator in front of each function name here. So you see Doug has a scope resolution operator in front. So this is going to tell the compiler that this function here belongs to the Doug class. That's what the scope resolution operator here means. We have the same on our getters. So we have our scope resolution operator. You can see that on get name, get breed, and get age. You see that we also have that on our setters. The setters are going to be setting data in our member variables. So we're going to set name, breed, and age. And our utility function is just going to print information about our class object. It's just going to print Doug. It's going to say the memory address where the object lives. It's going to print the name, the breed, and the age. And we're going to see that on the console. So this is our class. If you don't want to type it, you can get it from the resource section of this lecture, and you can start using it right away because this is going to take some time. But I do recommend spending some time to type this code in because this is really how you learn. Another thing I haven't explained, I think, is the include guard here. This is going to prevent people from including this twice. So the preprocessor is basically going to come in this file and say, if this thing here is not defined, I am going to define it, and then I'm going to include whatever I have in this file here. If this thing is already defined, it's not going to define this, and it's not going to include what we have here. So we have learned about this before, and we are reusing this here. So now that we have this class, let's try to use it in main. We're going to go to the main CPP file, and we're going to include our Doug class. And we say that by saying quote and inside put in the class header file. And now that we have the class included, we can try and use it in the main function. So we're going to say Doug and say Doug1. And we're going to pass in the information to use our constructor. We're going to pass in the name, which is going to be Fluffy, like always. We're going to pass in the breed, which is going to be Shepherd. And we're going to pass in the age of the dog. Now that we have this, we can try and print information about this dog. So we're going to say dog1 and say printful. This is going to call our printful function that we have in the class. So if we go back to the class definition we have in dog.h, we're going to see that printful is going to print information. But another thing you can do in Visual Studio Code is right click on the class and say go to definition. When you do that, it's not going to do that. So this doesn't work in Visual Studio Code, but we can go and find the definition for the function ourselves. So printful is going to print dog. It's going to say the address of the object, and it's going to print information about our object. So we're going to have name, breed, and age printed out here, and we're going to be respectively printing our member variables here. So let's go back to main, and we're going to try and build this program with GCC. The build is good. We can bring up a terminal and say clear and run rooster. Now you're going to see that we have the information about our dog object here printed out. We say dog, we say the memory location for this object, and we're going to say information about this dog, the name, the breed, and the age here. All this information is available. We can use our setters. So for example, we can go in here and say dog1 set name and change this to Milu, for example. Why not? And it's going to be Wirefox. We're going to set the name, nothing else. So we're going to say Milu here, and we're going to print the information again. We're going to say dog1 printful. And if we do that, you see that the program is going to work. Visual Studio Code is not complaining. If we try to compile this program with GCC, you're going to see that the build is good. And if we run, we're going to see that our setting has applied to our object. The name is Fluffy, then the name is Milu. So the set name function here is doing its job. Now, what we really want to see in this lecture is how to work with const objects. So we're going to change this dog1 object here to be const. Let's do that. And the moment we do that, you're going to see problems pop up. We change this guy to const here by appending or prepending the const keyword in front. And if we try to build this program, we're going to pass this through GCC. We're going to get compiler errors. And you see that we have a few squiggly lines here show up. The first problem that we really expect is when we try to set the name, because this object is const, we can't really change any of its member variables. So if we try to change the name, the breed, or the age, we're going to get a compiler error. And here we have that compiler error. We are trying to change the name of a const object, so we can't do that. We're going to get a compiler error. So we're going to see the message here which says that we have a problem at line 9 in our code. If we go to line 9, you see that we are calling printful, but we're not going to look at this just yet. And we're going to see that we have a problem again on line 11, which is what we are interested in looking at now. But it's also going to say that we have a problem with our setName function call here we have on line 11. And it's going to say that const dog as this argument discards the const qualifier. So what the error here means is that we are trying to modify our const dog object through the this pointer, because the setName function here is going to be using the this pointer to set the member variable. So what I haven't really explained here is that, for example, if we use the setName function, let's look at the definition. We say mname equals name param. What the compiler is really going to generate in the background is use the this keyword or the this pointer, and it's going to say this mname, then it's going to say equals name param. This is what the compiler is going to do. And going through the this pointer, you can really modify this object. So this is what the compiler is saying here. It's saying that this pointer that you have in your function call is going to discard the const qualifier we have in the main function. In other words, you can go through the this pointer and modify a const object, and we can't allow you to do that. We're going to give you a compiler error. We actually have the same problems with our calls to printful, because that's going to do the same thing through our function calls. So let's go back to the definition. You see that we are accessing mname, mbreed, mage. We are actually not modifying anything in this function, but the compiler doesn't know that. We know that we are not modifying our function, but what the compiler is going to look at is the signature of the function here. And if you look, there's really nothing telling the compiler that this function couldn't modify our object here. That's why the compiler is stopping us from doing this altogether. So the compiler is going to look at what we do here. It's going to change our references to the member variables to this using the this pointer. So it's going to say this mname, it's going to say this mbreed, and it's going to change this to this mage. And it's going to see that we could go through the this pointer and modify stuff about our object, and it's going to stop us from using this function altogether on const objects. You have seen that this function was working when the object wasn't const, but now it is const, and we could go through the printful function to modify our object. The compiler is going to give us a compiler error here. Hopefully you can understand this, and I want you to know that this is the case. So let's say that this is a compiler error. So this is the problem I want you to see with const objects. If you flag your object as const, you won't be able to modify the object through the setters, but no other function is going to work anymore, because the compiler is going to think that you could go through those functions to modify your object. So some of you might be saying, what if we try and go through pointers and references which are either const or not const? Let's try and see that. We're going to comment this out, and we're going to say direct access here, meaning that we are going directly through the object name to try and do stuff. We go through the object name and call printful, we're going to get a compiler error. We go through the direct object, we try to set the name, we're going to get a compiler error. This is what we mean here by direct access. Okay, so let's try and go through a pointer to non-const and see if we can access these functions here and do things with them. We're going to go down here and set up a pointer. We're going to say dog pointer. It's a pointer to non-const, so it's just going to be a dog pointer. We're going to say dog ptr, and we're going to initialize this with the address of our dog object. Let's say that dog1. And the moment we do that, we should get a problem, because this is a non-const pointer we could go through it to modify this object here. And if we even try to compile the code by now, we're going to get a compiler error. Okay, we have our compiler error, and what the compiler error is going to say is we are passing a const dog as this argument, and this is going to discard our qualifier. Why is that? We're not doing that here. This was from before, but if we go down here, we're going to see a compiler error that says invalid conversion from const dog pointer to dog pointer. So what we have to the right of the assignment here is really a const dog pointer. It is a pointer to const because we are using a const object here. But what we have on the left of the assignment here is a non-const pointer. And the compiler is going to notice that we could go through this pointer and modify this object here. So it's going to stop us from setting up this pointer altogether. So this is not going to work either, and it is what I wanted you to see. Okay, so a non-const pointer is not going to work, but what about a non-const reference? Let's do that. And we're going to set up a non-const reference to our object. We're going to say dog reference and say dog ref. And we're going to assign dog1. And we're going to get the same behavior. This is a non-const reference, and we are trying to assign a const reference to a non-const reference. If we're trying to compile the program, let's do that. We're going to get the same compiler error. And you see binding reference of type dog reference to const dog reference. So this is going to not work. We're going to get the same compiler error because we could go through this reference and modify this const object. The compiler is going to stop us from doing this altogether. Okay, this is not going to work. Let's comment this out. Okay, some of you might be saying, what if we change our pointer to const? So we can go down here and say that. Let's say pointer to const. And we're going to set up a const dog pointer, which is going to be const dog ptr. We can call it like this. And we're going to assign the address of dog1. And if we do this and compile, the compiler is going to trust this pointer now because it is a const pointer. We can't go through this pointer to modify the object we are pointing to now. So the compiler is going to trust us with this pointer. If we build, you're going to see that the code is going to build. So this is a good step forward. But if we try to do anything with this pointer, let's do that. We're going to say const dog pointer. And we're going to say set name. And we try to set the name to Milu, for example. This is not going to go well because we are trying to go through a const pointer to modify stuff. So this is going to give us a compiler error because we're not allowed to do that. We can't go through this pointer and modify our object. We're going to see that the compiler error is saying const dog as this argument discards the qualifier of const, so we can't say set name through this pointer because we are pointing to a const object. And this is a pointer to const. So this is expected because this is a pointer to const. We really expect not to be able to go through the pointer to modify the object. But even our getters are not going to work. So if we say const dog pointer and say get name, for example, this is a getter. It's really not modifying the object, but the compiler doesn't know that. It doesn't know that this function isn't modifying our object. Because what really the compiler looks at is the signature of the function. It's going to look at get name. Let's look at that. It's going to look at this function and it's going to say, there is nothing telling me that this function couldn't modify our object. So I'm going to stop you from trying to even call that function in the main function here. If you try to call it, I'm going to throw a compiler error. That's what the compiler is going to say. And if we try to build, let's do that. We're going to get a compiler error and it's going to say the same thing, that this argument that is used in this get name function. And if we go in get name, again, the compiler is going to see what we do here and it's going to change this to return this name. And it's going to say you could go through this pointer here and modify this object. So I am going to stop you from doing that. That's why we have this compiler error. Pointer to const isn't also going to work. So what if we use a const reference? We're going to go down and try to use this. We're going to say const dog reference and say const dog ref. And we're going to assign dog1, what we always do. Now the compiler is going to trust this reference because it is const. Let's try and compile and really prove this. You see, the build is good. But again, if we try and go through this and do anything, we're going to say const dog ref and try to set the name, for example, and we're going to change the name to Milu. That's what we want to do. And if we compile, we're going to get a compiler error. Let's do that. We're going to use GCC. You see, we have a compiler error, and the compiler error says this argument could be used to modify the object. So I want to let you use set name here. That's the compiler error, and we expect it because we are going through a const dog reference, and we can't really go through a const reference to modify the object we are referencing. So this is expected. But what is not expected is not to be able to even read stuff from our const object. So for example, if we say const dog reference and say get name, let's use this here. We expect this call to work, but if we build, we're going to really be surprised that it is not working. Again, the compiler error is going to say const dog this argument discards the const qualifier because we could go through the this pointer inside this function definition and modify our const object here. So I am going to stop you from doing that, and I am going to throw a compiler error. This is really what I wanted you to see in this lecture, that when your object is const, you're going to be locked away from using your object. And it is practically useless because you can't either read from it and you can't write to it. We're going to stop here in this lecture, and in the next one, I am going to show you that you're going to have the same problems if you try to use this object as an argument to functions. Then in the following lecture, I am going to show you how we can solve this problem. So go ahead and finish up here and meet me in the next lecture.